I'm going to go through the solutions for quiz 3.2. Number 1 says you spin a spinner labeled 1 through 10 once. Each number is equally likely to be chosen. Let A be the event that you get a multiple of 3. So for event A, we can get a 3, 6, or 9. And let B be the event that you get an even number. So B is going to be a 2, 4, 6, 8, and 10. All right. Are events A and B mutually exclusive? Explain. And we're going to say no, because the probability of A and B happening at the same time is the probability of getting a 6, which is 1 out of 10, and that's not equal to 0. The definition of mutually exclusive means that the probability of A and B would equal 0. Here we're showing it's not equal to 0, therefore it's not mutually exclusive. Are A and B independent? Well, A and B are independent if the probability of A is equal to the probability of A given B. Well, the probability of A happening, probability that you get a multiple of 3 is 3 out of 10. And the probability of A given B, well, out of B, so there are 5 options if B happened. And out of those 5 options, how many of those options belong to A? Well, only the 6. So 1 out of 5. And notice that the probability of A is not equal to the probability of A given B. So A and B are not independent. All right, number 2. Suppose the probability of A is 0.2 and the probability of B is 0.3. Find the probability of A and B if A and B are mutually exclusive. So we're telling you that A and B is mutually exclusive. Well, what does that mean? That means that the probability of A and B is equal to 0. That's the definition of mutually exclusive. Okay. Find the probability of A and B if A and B are independent. Okay. So if A and B are independent, then here's the formula. The probability of A and B is equal to the probability of A times the probability of B. Probability of A is 0.2. Probability of B is 0.3. And so we get 0.06. All right, find the probability of B given A if A and B are mutually exclusive. Well, the probability of B given A, using the formula, is the probability of B and A divided by the probability of A. Because A and B are mutually exclusive, the probability of B and A is 0, and the probability of A is 0.2, and 0 divided by 0.2 is still 0. And find the probability of B given A if A and B are independent. Using the same formula, we get 0.06 from B, and the probability of A is given to us at 0.2. We multiply top and bottom by 100, we're going to get 6 out of 20, or 3 out of 10. If we want to change it to a decimal, we can get 0.3. Okay. Number 3. Find the following probabilities using the table. So I'm going to find the row sums and the column sums and the grand total. So we end up with 13, 15, 20, 18. All that adds up to 66. Here we end up with 44 and 22. Okay. So probability of selecting a senior, well, there's 13 seniors out of 66. Probability of failing a freshman, or sorry, probability of selecting a freshman and selecting someone who's failing. So just by default here, there's an and there. Even though you don't see it, it's meaning it, the way it's written, meaning has to apply to both. There are 3 that fall into the category of failing and freshman out of the 66, and we can reduce that to 1 out of 22. Sophomore or passing, well, here we have, there are 20 sophomores. There are 44 passing, but be careful, when we add 20 and 44 together, we double count those that belong, the 11 that belong to passing sophomores. So I'm going to have to subtract 11 out of that, and this is all out of 66. And this comes out to be 53 out of 66. And the probability you're passing given you're a junior, so change the denominators, no longer out of 66, it's out of all the juniors. There are 15 juniors. Out of those 15 juniors, 13 are passing. All right. On to number 4. Excuse me. Find the following probabilities using a tree diagram. A says find the probability it's a rainy, windy day. So it's rainy and it's windy. So you got the 0.4 for being rainy, and you have the 0.8 for being windy. If we were to write this out, this would look like this. The probability that it's rainy and windy is equal to the probability that it's rainy times the probability that it's windy given that it's rainy. And that's what we're getting here. And we end up with 0.32. Find the probability that it's windy given that it doesn't rain. The probability that it's windy given no rain. All right, so we go down the no rain path. Then we see that there's a 30% chance, so 0.3, that it's windy. Find the probability that it rains and is windy, or that it does not rain and is not windy. Okay. Oops. So the probability that it rains and is windy, or the probability that it does not rain and not windy. Okay. Well, the probability it rains and is windy we did in number 4, part A, so that's 0.32, plus the probability of no rain and no wind, that would be the probability of no rain, times the probability of no wind given no rain. So that's 0.32 plus no rain would be 0.6 times no wind given no rain would be 0.7. So 0.32 plus 0.42, which is 0.74. So there is a 74% chance of that occurring. All right, on to number 5. 3 math teachers will be chosen out of 10 math teachers to teach the same 2 math subjects out of 8 different math subjects. And how many ways can this happen? So you have the teachers. You're choosing 3 math teachers out of 10. So you have 10 options for the first pick, and then 9, and then 8. But remember, order doesn't matter here, so we're going to divide by 3 factorial. So that tells you how many different ways you can select 3 math teachers out of 10. But then once you do that, then you got to choose 2 math subjects out of the 8. So there's 8 different math subjects, so you have 8 choices for the first, and then 7 for the second. Again, order doesn't matter. And so the second factor here is how many different ways you can select 2 math subjects out of the 8. So simplifying these, just putting everything together into one fraction, you have 10 times 9 times 8 times 7 over 3 factorial, so 3 times 2 times 1, and then 2 factorial, 2 times 1. And then you just simplify that down. Once you work through that, you end up with 3,360. Number 6, John has a small class. He has 10 student desks and only 8 students. How many different seating charts can John make? Well, so we're going to think of, well, we have 8 students. So the first student you have 10 different choices in terms of what desk they're going to sit in. And then the next student, you're going to have 9 choices. And then the next student, you're going to have 8 choices, all the way down to that last student. That last student is going to have 3 choices left. Each of these represent a student, so you're going to have 8 numbers here representing the assignment of the desk to that student. And here, order does matter. It's a seating chart, the position of the desk, and the particular student assigned to that desk does matter. So we're not going to divide by anything, and we end up with 1,814,400 ways we can do this. Quite a few. How many distinguishable words can you make from the letters in the word excellent? Well, you count how many letters there are. 1, 2, 3, 4, 5, 6, 7, 8 letters. And then look for repeats. We have 3 E's that repeat. We have 2 L's that repeat. And I think that's it. And then you simplify that down and you end up with 3,360, which ends up being the same answer as number 5. Number 8, one card is picked at random from a deck of 52 cards. What is the probability that it's a heart or a red card? Okay. Well, notice that all red cards are hearts. Right. So the probability of selecting a heart or a red card is going to be the same as the probability of selecting a red card, because hearts are part of the red cards. And half the deck is red and half the deck is black, so probability is 1/2. 9, a number cube, which is a die, is rolled 3 times, so it's got 6 sides. It's a cube. What is the probability that the sum of the 3 rolls will be 9, given that the second roll shows a 1? Okay. So we know we have your first roll, your second roll, and your third roll. And we have some special information here. We know the second roll is a 1. Okay. And we want the sum to be 9. So we want to add up to 9. So we need the first and the third to add up to 9. Sorry, to add up to 8. Okay. So we can answer this pretty easily by making a little table here. So here's the first roll. And here's the third roll. We can kind of ignore the second roll because we know it's a 1. And we want the first and third roll to add up to 8. So I'm going to put a sum chart in here, or sum table in here, and look for 8s. And so we see that I've circled 5 8s. And so there's 5 8s out of the 32 options, or sorry, 36 options. And so 5 out of 36 is the probability that we want. All right, there are 6 coins in a bag, all having a different value. A penny, a nickel, a dime, a quarter, a $half, and a dollar. You randomly pick a coin out of the bag until there are no more coins. What is the probability that you first pick the quarter? Okay, so there's a 1 out of 6 chance that you pick that quarter. And then you pick the penny, so then there's a 1 out of 5 chance that you pick the penny. And then you pick the dollar. There's a 1 out of 4 chance. And then the dime. And then the nickel. And then the $half. In that exact order. So that comes out to be 1 out of 720 chance. And there is the end of a quiz. I hope you got some of these problems right.